Hello everyone, today we have one interesting coding problem which is power grid maintenance. So in this LeetCode problem, we have given power stations like 1, 2, 3, 4, 5 which are represented in 2D matrix like this, and along with connections we have given queries. These are the queries which we have to perform on these connections. So these connections means in these power stations we have to perform two types of queries, query 1 and query 2, and we have to keep in mind that these connections are online, means are in working state. So the first query is represented as 1, x. X is a connection on which this query we have to perform. So this is x. This is what x is, and 1 is type of query. So this is first type of query, and 2 is second type of query. In first type of query, we have to do maintenance check, means we have to check this X connection is working or not, or online or not. If it is online, then we have to return. If it is not, then we have to return the nearest another connection which is online. And 2x means we have to make the X connection offline. Means main we have given queries like this in 2D matrix. We will iterate it to one by one. If the query type is 1, then we will do maintenance check and return the respective connection which is online. We have to note it down that only during 1x query we have to return the connection. Like here, let's take an example. Here C is 5, means there are total 5 connections, 1, 2, 3, 4 and 5 which are connected, and connections are represented as 1, 2, 2, 3, 3, 4, 4, 5, and the queries are 1, 3, 2, 1, 1, 1, 2, 2, 1, 2. So initially all are online. So these all connections are online. Then now we have to iterate through each query and do respective operation. So query 1 is 1, 3. That is 1 means we have to check maintenance check on third connection. So third connection is already online. So we will return maintenance check and we will return the third connection. So our result is 3. Then second query is 2, 1. 2, 1 means we have to make first connection offline. So this connection will become offline. So we have connection like 2, 3, 4, 5, and now 1 is offline. So next query is we do not have to return anything for 2x, we have to return only for 1x. So we have done with 1, 3 query, and now 2, 1 is also done. Now 1, 1 means we have maintenance check for first query, first connection. So as previously we have done second query on first connection to make this offline. So now on 1, 1 we have to do maintenance check on same connection. So this connection is offline, so we will return nearest online connection which is 2 here. So our result include 3, and now as 1, 1 query is also done, we have written smallest online in a same grid. In a same grid means in a same connection. So 2 is also returned. So 2 will be returned. Now next query is 2, 2 means we have to make this query on second component. So first we have done first connection, now we have to make second connection also offline. So 2 connections are offline. Now 3, 4, 5 are online. So next query is, we will not return anything. Only during maintenance check we will return connection. So now next query is 1, 2. So we'll do maintenance check on second connection. So 1 and 2 are already offline. So we will return 3 as 3 is online. So our total result will be, our final result will be 3, 2 and 3. So this is the how we solve this problem. Let's understand the basic or most important logic behind this. To solve this problem, we will use Disjoint Set Union or Union Find method, in which what we will do, suppose we have given a connection 1, 2, 3 and 4. So what we will do, we will store parent of each connection. Like here parent is 1, second parent is 1, third parent is 1 and fourth parent is also 1. All these connections have linked with 1. So we will store one parent array. We will create one parent array in which we will store respective parent or root node. Here we can see one has connection with 2, 2 has connection with 3, 3 has connection with 4. So all these have a connection with 1 indirectly. So what we will do, we will create one parent array in which we will store all these connections as its respective parent. So this is done for finding the root. Or similarly, suppose we have another graph like 1, 2 and 3, 4, 5 and 6. Now here we can see that these both graphs are not linked with each other. So our parent array will be like this: 1, 2, 3, 4, 5, 6. Here we will store 1, here we will store 2. Now here we also store 1, and here also 1. Here we store 4, 4, 4 and 4. 0, 1, 2, 3, 4, 5, 6. As you can see, 1 is parent of this graph. So 1 has parent root as itself, which is 1. Now 2. Second node have parent 1. So we will store 1 as a second node parent. Similarly, for third node, its parent is 1. So we will store at third position also as 1. But in second disconnected graph, 4 has a parent 4, not a 1. That's why we will store at index 4 as a 4. At index 5 we will store 4, and at index 6 we also store 4, as 4, 5 and 6 have one root node which is 4, and 1, 2, 3 have one root node which is 1. So this is the parent, array which will store the respective root nodes. So this is the one thing, and the another thing is we have to maintain a map of respective nodes, root nodes. Let's understand this. Suppose we have two root nodes, like we have seen 1, 2, 3 and 4, 5, 6. In this case, 1 has 1, 2 and 3 as nodes, and 4 has 4, 5 and 6 as their respective child nodes. So we have to keep a map like this, so that when one goes offline, when one goes offline, we will select the nearest uh, child node which is connected to 1. Similarly for 3 also, we will return nearest child of 1 as a 3 if 1 and 2 goes offline. So let's see one example how we can do this thing. So this is the main function. First instruction of main function, which is function definition. Then we have C. We have defined a C as 5, as we have 5 nodes, 1 2 3 4 5 or 5 connections. Then fourth instruction is connections. We have given these connections which is in 2D array format. Then we have queries. Then we will define one parent array. This is parent array which will represent respective root nodes. Now we can see that this is size of parent array C++. Now we will iterate through loop. During iteration, what we will do, we will assign parent of 1 as 1. So we have total 5 connections. So each node have connected to itself. So connection of 1 is with 1, 2 is connected with itself, 3 is connected with itself, 4 is connected with itself, and 5 is connected with itself. So total 5 connections are there. So initially we assume that they are connected with itself only. Then we will iterate through connections. So this is the connections, like 1 is connected to 2. This is a representation of this graph. So this is represented in 2D array format like this, as 0 row first column, 0th column we have 1, and 0 row first column we have 2. 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, and 4 is connected to 5. And now we will iterate through each edges. So current edge is 1 2. It is pointed to 0th location. So what we will do, we will modify this parent array such that it will represent our current graph. So we will call union function, which will create edge between these 1 and 2. So in union function, what we are passing edge 0. Edge 0 is this one, edge 1 is this one. So 1 and 2 we are passing along with this parent array. So union is doing union. A means 0th edge and B means first edge. So PA is find A parent. What we will do, we will find the parent of first edge, that is edge A or node A. This is what we are finding, the root node of 1. So what is root node of 1? Which is 1. Let's find out with this find function. So here x is A, x is 1, as our pointer is pointing to first position. If parent x is not equal to x, so what is value of parent x? Parent x is this one, this is x, so parent x is 1. So it is not equal to x. No, these both are equal. So this is false. We will return parent x. Parent x is 1. Return parent x. So value of p is 1. Similarly, for second node, we will find the root node of second node. In the same way, we will find the parent x is equal or not equal to x. So parent x is 2 and this is x. So these are equal. So this is false. We will return parent x, which is 2 here. So PA is 1 and PP is 2. PA is not equal to PB, true, because they do not have any connection currently. As per this parent array, P is not equal to PB, which is true. Now what we will do, we will create one connection. Parent PB. PB means parent of 2 is equal to PA. P means 1. So this 2 will become 1. Now it is saying that second node have a parent 1, not a 2. First have parent 1, second have parent 2. So this is done. Now we will move to the next instruction. After doing union, we will continue iterating to next stage. Next stage is 2 and 3. So h0 is 2, h1 is 3. So we will call union function again. A is 2. Now this 2 is A and 3 is B. Now we will call find function here with A as a parameter with parent array. A is 2. A have parent x is not equal to x. Yes, this is true, because as you can see, A is 2. So here it is x. X is 2 now, because we have called find function. So parent x means this one. This is x. This is x and this is parent x. This is x. So parent x is not equal to x. So which is true. So we will call again with parent x to find the root of this node. As they are not equal, we will again call parent x function. Find function with parent x. So parent x is 1. Now check parent x is equal to parent x is equal to x. Yes. Now when we call with 1, both are equal. So this is false and we will return 1. So we have written 1 as the find function parent x. We will return 1. So P is 1. Now PB. We will call PB find function along with B as a parameter. X is now 3. X is not equal to parent x? No. Here both are equal. So we will return parent x as 3. Where it will be 3. Now PA is 1 and PB is 3. So P is not equal to PB, true. So what we will do in parent PB is 3. So instead of 3, what we will do, we will write their PA value. What is value of PA? Which is 1. We can see here value of PA is 1, what we will get? 1. So P is not equal to PB, true. Parent PB is equal to PA. So here we will get 1 as value. If int and function will get int. Now we will move to next stage, which is 3 and 4. Now again we will call union with A as 3 and B as 4. Now PA, value of PA is with A, we will pass A as a 3. Here A as 3 means X is 3. Now value of 3 is 1. So parent X is not equal to X. Here parent X is 1 and X is 3. Parent X is 1 and X is 3. So parent X is not equal to X. So this is true. So we will find the parent of 1. We will pass as parent X as 1 along with parent array. So parent X is now 1. So value of parent X is 1 and X is 1. So it is false. We will return parent X, which is 1. So we got parent X as 1 here. And we will return parent X, which is 1. So P is 1 and PB, which is here 4 and 4. PB is, we will call find function to find the PB. So B is 4 now. As you can see, B is 4. So X become 4. Now parent X. Parent X is 4 and X is 4. So it is false. They are not equal. They are equal. Return parent X, which is 4. So PB is 4 now. P is not equal to PB. So value of P is 1 and PB is 4. So it is true. So parent of PB is equal to P. So parent of PB means this one. Parent of PB means this one. So this will become PA. Value of PA is 1. So we will write 1 here. Similarly, again we will continue iterating to last, which is A here is 4 and B as 5. So we will call union function and we will find the connection between 4 and 5 with A as 4 and B as 5. Find PA. For finding PA, we will call find function along with A. A here is 4. 4. Here X is 4 and parent is parent array. Parent X is not equal to X. Yes, parent X is 1 and x is 4. Correct? So it is true. So we will call find function of with 1 as a parameter, as parent x is 1. Parent x is not equal to x. Now parent x is 1 and x is 1. So both are equal. So it is false, and we will return 1 as a find function's value. So parent x is 1. Parent x is 1. So we will write 1 as return value. Now PB. PB is 5. So we will pass 5. Here it is 5. Parent x is equal to x. So this is false. Parent x is a 5. So we will return 5. Now P is 1. PB is 5. So P is not equal to PB. True. So parent PB is equal to P. So value of P is 1. So we will erase this and write 1 here also. Now you can see all these are 1, which means everyone is connected with 1. So this if it ends, and we will return from union function as all are united with 1 node. Edge, every edge is traversed, so we will come out of this loop. Now we will require one map data structure to store the respective child nodes of a parent node. For that we have got one comp map data structure with name as comp map, which is storing integer value of root node and their respective child nodes in a tree set. Here we are using tree set to store their child nodes in ascending order, such that when one node is offline, we can pick up second respective node, which is smallest. So let's travel through this. Total connections are 5. We are incrementing by 1. So find I parent. I is 1 now. So what we will do, we will call find function to find the root of I node. Here everything is 1. Find the root of I. I means 1. So we will call to 1. Here it is 1. Parent x is not equal to x. No, both are same. X is 1 and parent x is 1. So this is false. Return parent x, this is 1. So we got root as 1. Now map. We will map 1, which is root. Here you can see root with respective child node. In this case, which is 1. As I is 1, so we will push 1 in this map. Now we will iterate to second. So this is 2 now. So root of 2 parent x is not equal to x. True. So we will find the root of 1, which is 1. So what we will do, we will return 1. So here again root node is 1. So root is 1 and the respective child is 2. So similarly we will refer to third connection and we will find that 3 has parent node as 1 and we will return 1, and again we will push that third connection also in the first root. Similarly for 4 and 5. And then, as we all know, we have to form one online array which will store the current state of a connection. So initially all the connections are online, so all are true. In the true state, we will create one result array in which we will store respective results. Let's move to respective queries. Like first query is 1 3. 1 means we have to do maintenance check on third connection. Type of query is, this is type, and this is connection. X is connection, which is 3 here. Root of 3 is, as you can see, root of 3 is 1. So after calling find function, we will get 1 as a root. So type is 1, which is correct. As you can see, 1 is type here. 2 is it online? Yes, because initially all are online. So result, we will add x, which is 3 in result. So 3 will get added in a result. Now next query, else is false as if is true. Type 2 is not there as type 1 was the query. Now next query. Next query is 2 1. So type of query is 2 and connection is 1, which is x. A root node of 1 is 1. So root is 1. Type is 2. So this is false. And type is 2 true. Is it online? Now we are checking 1 is online or not. So yes, it is online. So we will make it offline. As it is query 2, we have to make 1 as offline. So we will make 1 as offline. So this will become offline. Now we will remove x from root node. So x will be 1 will be removed from root node. If and now next query. Next query is 1 1. Means we are doing maintenance check on first node. So as all we know. One is offline, so we have to return the nearest neighbor, which is smallest. So type of query is 1, x is 1, as you can see, type of query is 1, type, and x is 1, root is 1, type is 1, true, is online, no, false. Now else is true. We will create one set in which we will get values of root, which are 2, 3, 4, and 5 in this set. Set is not null, it is not empty, so this is false. Else is true. We will add first element, which is 2, inside this set, inside the result. The result contains 2 now. Else ended, if ended, type is not 2, so we will move to next query, which is 2 on second connection. 2 means we are making connection to offline. So type is 2, x is 2, root is 1, type is 2, so this is false. Type is 2, true. Is it online? Yes, 2 is online. We will make online as 2 as false. So this is now offline. We will remove from map array also. Map contains 3, 4, and 5. Now we will move to next query, which is 1, 2, means we are doing maintenance check on second node. So second node is false, which is not online. So we will return nearest small node or connection. So type is 1, yeah, as we are doing maintenance check. X is 3, x is 2. Yeah, here you can check x is 2 here, last query. So root of x, root of 2 is 1, so root is 2, root is 1. So type is 1, correct. Is it online? 2 is online? No, 2 is offline. In previous query we made this offline, so it is false. Else is true. We create one set and get root node. Root node is 1 and respective childs, that is 3, 4, and 4, 3, 4, and 5. So it is not a null, or it is not empty, false. Else is true. We will add first element, that is 3, inside the result. So this way, type is not 2, it was a 1, as we are doing maintenance check. In this way, for loop is iterated successfully, and we will print result, which is 3, 2, and 3 as our final answer. So that's it.